Okay, welcome back. So we're now going to move on to the second step, which is importing the land use maps. Remember, we opened up the switchboard, yeah, and then we worked through, we imported the regions, and then now we're going to import the land use maps. This is a floating dialog, so you'll have it somewhere on the menu, so don't worry if it disappears. It's going to be there somewhere. Import the land use maps, number 2. We'll see it's going to ask us to choose an initial land use map, right? So the way APoLUS works, like most of the other cellular automata land use models, is you work from a starting point, a starting historical map. So in this case, it could be 2000, a map of land use in the year 2000 that we've previously classified into a number of basic categories. And then you apply rules. You apply cellular automata neighborhood rules, accessibility rules, suitability rules, zoning restrictions, and in APoLUS, actor characteristics, which can influence the uptake of a particular land use in a particular territory. You apply all these things to your starting map, your initial land use map, and then to calibrate the model, you try to simulate through a trial and error process a second historical map. So in this case, we obviously work with the first map, which is of the year 2000. We're going to try and calibrate our model by simulating the year 2007. And once we're happy with that, we can use a range of different map comparison statistics. Once we're happy with that, we can then could then run the calibration, that calibrated model, through to a third historical date. In this case, we have 2012. If performance is still good at that date, we can call that, we can say that the model is validated. And then at that point, we can then set our 2012 map as our starting map and run the model forward into the future to see how our tendencies represented by our different model drivers are going to play out in the future. So that's how that works in a nutshell. So let's get started. To choose the initial land use map, again, these are all stored in the ASCII directory. Okay. Yep. And here we've just been to regions, so now we're going to go to land use. So this is where you need to put your land use maps. We'll talk about those in just a second. So here, F for final land use 2000. So that's a TIFF file. It can actually be pretty much any geographical file. This originally was called ASCII because we worked with raster package without RGDAL installed, and that permitted us only to use ESRI ASCII files. It's quite a large file for a perfectly good format, transparent, easy to read, but quite large, quite heavy. So often better to use a more efficient file format like TIFFs. But yeah, there's numerous different types of raster file. As you know, anything that's supported by the GDAL libraries will be supported here by Terra. So this is Terra's going to do the process of importing this. Okay, so then let's just go to that, import that. Okay, it's telling us what it is. And then it's asking us for a final land use map, right? Because for the calibration map, for the calibration of the model, you need two maps. You need the starting map and then the second map that we're going to use for comparison to see how well we've done our calibration. So there we can just choose the land use 2007 map. Okay, it's reminding us where it is. Okay, and it's brought it up there and it's plotted it out. And to those nice attractive colours, I should point out that this is something that obviously I've worked on when setting up the model before getting to this stage. So you obviously need to set your model categories. So there we've got 7 categories. And this is something you need to do previously. You do your own reclassification of your map, reclassify it into. I don't recommend having 2 categories. I think somewhere between about, you know, 5 to 10. I wouldn't recommend having many more than that. Things can get very, very, very complicated. The more categories you've got, the slower the model will run. The more categories you've got, the more rules you have to think about. In general, I think that's probably not a good idea. So just you know how this all works. This is inside this script here, start land use. We can just have a look at that, this here is obviously it's just the code that runs that dialog box. That's what we've just called up, here those maps are plotted because we've set these breakpoints for the categories in our map, and we've set these different colors to represent each of the categories. So that's something that you will have to modify yourself inside the start LU map if you want those colors to plot out nicely like that. Okay, so now this is one of the kind of, if you like, one of the quirks. The system, it's not an integrated application. I'm not a software developer. I have no particular desire to become one. So it's a mixture really of dialogues which try to help you out, and other places where you're going to have to be attentive to what it's asking you for in the command line. So this is one of these points, and it's asking us for the start year. Well, this is just something that you're going to have to enter because you're going to know that, obviously. So we know that our starting year is the year 2000, and we know that our end year, as we saw with our map, is the year 2007. Okay, so it's gonna compare. What it does then is it compares those two maps, and it says, oh, actually, in one of the maps, in the first map, there's a missing category. There aren't the same number of categories. Okay, so this is kind of a key problem, because you obviously can't grow a category forward into you can't increase the size of a category to a new date if that category doesn't exist in the first place. So you need to tell the model basically to create it and to give it an area of 0. It's that simple. So what it's asking you here, it's saying what is, obviously we can have any number of missing categories. You know, we might have 3 or 4 categories that only appear later on. No problem, we can handle that, but we just have to tell the model which they are. And so what you've got here is we've got the values of those categories that we defined in our model when we went in our map, and we made our reclassification. Okay, so 1, 2, 3, 4. Oops, and we haven't got category 6. We haven't got category 5. Sorry. So there we just tell the model that our missing category is 5. Okay, and there's only one missing category, so therefore we can just follow the instructions above. Always read the instructions, tells you what to do, and just issue 999, and that'll quit out of the dialog, right? And then it will go into land use. You go into the second land use model, right? And it will say, oh, are there any missing categories? Well, in this case, in fact, there are no missing categories, so we can just exit that straight away. Don't need to worry about that. Okay, there we go. So that's that part set up. Now what we're going to do is we're going to set up our different land use categories, right? So what I'm going to do here is I'm just going to show you how this works. So once we, if we work right from the beginning, we're going to need to give our land use categories names. So we've got 7, numbers 1 to 7. What are they called? We're also going to need to give them a status which determines how they behave in the model. In very simple terms, passive, we have the first set of categories are what are called passive categories. So these are things like natural areas, could be unproductive farmland, could be bare land, could be scrub land, depending on where you're working. These are categories that basically don't really do anything in our model. They sit there and they get built on, they get irrigated, they get turned into mines or quarries, but they don't do anything. They sit there. So that's why we call them passive. The second type of category that we have in these models are called active categories, and these are the categories that do the growing and the building or the intensification. So obviously we want to, if we're interested, for example, in modelling urban land, we obviously want our urban land to be an active category. In this case, our case of Navarre, we're interested in modelling the development of renewable energy. So we've got solar panels, so our solar category is active, and our wind farms are also an active category. So we've got 3 active categories. I don't recommend to have too many categories. I think it's better to have a few active categories to focus on the interactions of a few important land uses with each other, with the passive categories. Otherwise, things are very confusing. And finally, the last class of category is called the static categories, and these are things like which we don't expect to change in our model. So typically these are going to be reservoirs, rivers, lakes, the sea. If you've got large areas that can't be developed or are not going to be developed. In very urban applications, people often include airports in the static category, because over a period of time modelled, they generally would not change. Okay, so what we're going to do now is we're just going to show how that works. So when you create this, when you create these categories, so we're going to go into interactive mode. On our first category, we're then going to call natural. I'm going to cheat a little bit here. I'm just going to remind myself. So when you create these categories, they get stored in the outputs folder, and they get stored in this file called land use CSV. So obviously you won't have this if you're creating these from scratch, but I'm just going to remind myself of what I'm doing, make things move a little bit faster. So our first category is nat. Okay, and it's a passive category. The passive categories must all go at the beginning. The order is very important. Passive categories followed by active categories followed by static categories, right? No other order is acceptable, and you cannot mix them. Okay, so returning to that, whatever that was just there. Okay, our second category we called actor influence. So the actor influence is an important feature of the APoLUS model. At present, when you set the actor influence, if you can set the actor influence for various categories, you can say the actors will influence various categories, but the actor influence is all the same for all categories, right? I'll explain a little bit how the actor influence works in a bit, but it's important to bear that in mind. So obviously, if you think there's going to be quite a lot of different kinds of dynamics going on, you need probably to choose one of these that you're most interested in. And in this case, I think we're most interested in this model in the behaviour of actors with respect to solar energy. So we've just set actor influence there for solar energy and nothing else. So basically what we're saying is that none of these other categories are going to be influenced in this model by actors. That doesn't mean they can't change. Indeed, they will. The cellular automata land use model will make them change. Just that the actors, we're not specifically modelling the influence of actors. Okay, so that has no actor influence. Category 2 we called agri. This is a passive category. This is dry land agriculture. There is no actor influence. Category 3 I think was urban, if I'm not wrong. Yes, was herb. Okay. Okay. Very important, this is an active category. If you don't call it active, it can't. It'll just get eaten up by everything else. Active. So the active categories are the ones that are they're occupying other categories. Okay, the dynamic land use classes in this model. We're not interested in the influence of actors on urban land use in this model. Yeah. So this is about being pragmatic. I'm not saying that different types of actors in the planning system don't influence urban land use. Obviously they do. What I'm saying is in this model, that's not what I'm looking at. Okay, so that's important to be pragmatic in that way and focus on what you're interested in, and leave the other things. If you try and do too many things at once, it makes it very hard. Remember, important to remember, models are intended to be a simplification and they're intended to be a tool. So we shouldn't look for an Uber model that tries to do everything all at once, because that just won't work. Okay, so category 4, this is the one where our actors are going to influence. So this needs to be an active category, and we have 1. We turn on the switch for active influence. Okay, so so category 5, this is wind. Yep. This is also active, and we're not going to model active influence in this case. Okay, so notice here I've got 2 passive categories. These have to go at the beginning, followed by 3 active categories. Those have to go next. And then finally I've got 2 static categories, which are water for our reservoirs and our lakes, and outside, which is just the white space outside of the model, which obviously does not and cannot change. Okay, so category 6 is water. These are static. Those are static categories, they cannot change. We can just put here a 0. It doesn't matter what we put because they do not change. Okay. Okay, and this category 7 is outside. And again, it's static. And we can just put a 0 in there. Okay. So at this point, what it then does is it then calculates what the rate of land use change would be from that first initial map on the left and that second map, in this case for 2007, on the right. So that's what that's doing, demand and annual demands calculated. So that basically means that if we just go and run the model, once it's calculated that, it's just going to calculate the tendency of change towards from the beginning towards the final land use, just according to the pattern of historic change, which is just simply the difference between the land use, the area of land use, the number of cells in the second map and the number of cells in the first map. Of course, it won't work because we haven't put any rules in our model yet. So that is the absolutely key thing. Okay, so it takes a couple of minutes to save. One of the things about these is it doesn't always return you the cursor, so it's good to just hit enter occasionally and see how it's getting on. Yeah, there you go. So that actually done absolutely fine. It's given us a couple of warnings. So all of these scripts are designed to clean things up as they go along. So if there's things there you haven't used, it just throw a warning saying it's not there. But that's the purpose. It's cleared up a few of those other things. So so that's that part of the model complete.